Here. And with that, I'll hand you over to Oliver, who's going to talk about ClojureScript.
Thanks, David. My name is Oliver Mooney. I work with GetBulb. We do a lot of data visualization. We have a JavaScript app that works in the client. I wanted to do a kind of talk that looks like ClojureScript. And I gave this talk before to a ClojureScript meetup group about a month ago. But they already knew Clojure, so I put in some more introductory stuff into this. It compares JavaScript as you know it now against the next version of JavaScript called Harmony, and then against ClojureScript again. Before I go on, I should say as well, I'm Irish. I talk very quickly, so if anybody doesn't follow me or says slow down, just put up your hand. Tell me to slow down, it's fine. So, just to get started again, I'm only talking about the JavaScript parts that are good. I'm ignoring all the crappy stuff that wound up in there over the past 10 years. So it's Douglas Crockford's book around 2010 that came out to find the good parts. They're listed there, and none of the crap that's in there, like the weird scoping rules, the global variables, all that stuff. I assume you guys know about that and avoid it. Most modern JavaScript programmers know about that and know what not to do. The next version of JavaScript that's coming out is codenamed Harmony. It takes a lot of ideas that you found in languages like CoffeeScript, which was compiled into JavaScript. It's now becoming default parts of the next version of JavaScript. It codifies good practice, and you can use it right now in production. You don't have to wait until the browser supports it. There's what's called a transpiler that will suck in your ES6 code, convert it into ES5 or ES3 versions of JavaScript that run in all browsers today. Sorry, just ES5. ES5 is supported in all browsers except for IE8 and below. ES3 is what IE8 runs, so you can only use a limited version of ES6 or Harmony in that browser. But you can still use 95% of it there. The same translation idea is what powers ClojureScript. ClojureScript sucks in the Clojure programming language, which runs normally the JavaScript virtual machine, the JVM. It's transpiler driven. It converts that ClojureScript into a very, very limited version of JavaScript, and then Google's Clojure, CLOSUR rather than CLOJUR, that compiler takes that version of JavaScript and minifies it and optimizes it. So you get some very, very efficient JavaScript at the end of that process. It'll run in any browser as well. It's a kind of a painful process day to day to use. It takes a while for the browser to do its thing, for the compiler to do its thing, but you get great code quality at the end of it. So I wanted to have a look at the languages themselves now directly. There's a huge philosophical difference between ClojureScript and JavaScript. ClojureScript calculates with values. If you define something in ClojureScript and you call it Oliver, and you define Oliver as 42, if you look up Oliver, you're always going to get 42. That value will never change. You can't ever redefine Oliver to point at something else. In JavaScript, you're always redefining things to point at something else. You're redefining boxes of state to hold different values over time. It's a challenging way to think about programming. Once you do it, it's actually much simpler. You can calculate in your mind a lot more easily how your program is going to evolve over time. And it actually means that you become a better programmer because you're doing less. It takes away control of managing state over time, but it does mean you can do a whole lot more with that. It also takes advantage of what's called functional programming, which I'm sure you've all come across, where you have first-class functions, so you can calculate with functions and pass them around to other functions and get functions back as answers. It does push you as a programmer, but it does mean you get a lot done in the same amount of time, with a lot less thinking, actually. This is just a quick example of what that means. I don't know if you can see that on the screens, but what I'm doing here is defining two separate objects. This is just plain JavaScript. The first one is, two object literals here with an age field and a name field, and the name field has a first and last field inside it. Person A and person B, they're the same except the first name is different, Jane instead of John, and the age is different, 22 instead of 32. Now in JavaScript you can't compare these objects directly. You can't go, is person A equal to person B? It just doesn't give you that functionality. Whereas in ClojureScript you can. You can define in a very, very similar script the same fields, the same different values, and person A and person B, you can see if they're equal or not, just calling by their name. And it doesn't matter how complex those values get. You can have any number of nested objects, nested literals, nested arrays in those structures, and you can just do is A equal to B, and it'll tell you yes and no straight away. That's what I mean by calculating with values. The values don't change over time. They always mean the same thing. So just looking at the three different versions of the languages here, there's current JavaScript, which is ES5, ES6 is Harmony, and then ClojureScript CLJS. ES5 doesn't currently offer function literals. You have to do the full fat function definition here to do a squaring function. JavaScript 6, sorry, the next version of JavaScript will let you use the shorthand here where you can just pass in the values of the function and use the arrow like you can in CoffeeScript at the moment to get back the function execution, the function body I should say. And in ClojureScript, the syntax of the language is different. You have the bracket to open and close the function. The function name is here. This is the values that the function is operating on, and this hash, open and close, is the function definition. It's very, very terse. This %1 here refers to the first parameter passed into the function. So it's a very, very short, brief way of specifying a function. And that encourages you to use very, very simple, small, tiny functions anywhere you need to very, very quickly, and just get out these very lovely, brief nuggets of computation that you can use again and again and again. That's the very low end. At the very top end, both of them are very familiar with the classic OO model. JavaScript 6 takes the prototype model that JavaScript currently uses. It puts a bit more vocabulary around it, so you can now define a class directly. You can extend existing classes. You can call to the super class, and you can have private fields. You have private methods here as well, and static methods too. It's very similar to static typing that you get in C++ and friends. ClojureScript is a lot looser. It allows you to define protocols and then define types and records, which are extended versions of types using the same protocol that you defined it up here. So here you have a cache that follows the iSound protocol. The iSound protocol has one method, sound. Here you tell it you want to implement the iSound protocol, and that's the function application. So it's always the function to follow that protocol, which is defined here. And it goes all the way down. It's just a very, very succinct way of specifying interfaces, protocols. They're equally functional. I think the ClojureScript version is nicer because it gives you a set of protocols for free that JavaScript doesn't necessarily offer. But again, it's a tasting. Object literals. You've seen these. They're open bracket, close bracket, field name, and field value definitions that come out very, very quickly. JavaScript, the current version, tends to shove a bunch of hidden things in there, like index of and various other methods you don't necessarily want. JavaScript 6 doesn't do that. It doesn't do anything hidden. It lets you define what the prototype is yourself and gives you a nice shorthand for doing so. And it can also implement a hierarchy for subsets, supersets and subsets. ClojureScript doesn't really have a direct analog because it's not object orientated, but it does have a serialization I suppose serialization format, you call it, similar to JSON, called EDN. It can capture everything that a ClojureScript value can be, arrays, dictionaries, everything else you can think of. It's actually richer than JSON, and it's a great way to communicate with Clojure on the server. So you can transfer richer varieties of data between server and client without having to have extra versions of JSON based on your date format or the type of color you're converting across between the two of them. Template strings, this is where you interpolate values into strings. JavaScript 5 doesn't really have them, and you only have strings over a single line. ES6, the next version, will let you have multi-line strings, like this one here. You can have /ns inside a string if you want, and also interpolate values in there. So you have hello $name for a variable called name, hello $time for a variable called time. ClojureScript doesn't really have anything directly comparable, but because you can manipulate the language very, very quickly, you can use a language called Strint here, which is string interpolation. It's the same interpolated value named here using that syntax. It looks as if it's at the language level, not the library level, because of how malleable ClojureScript can be, how you can manipulate it using ClojureScript itself, which I'll come back to again. Destructuring. Destructuring is a great way to dive into an object without having to unpick it by hand. So, for example, to match a list, if you're passing an array of tree values 1, 2, 3, and you want to pull apart the tree values without diving in by hand, you can just specify how you want to match it. A, comma, blank to ignore it, and comma, B to against. And after that line of code is executed, A will equal 1, and B will equal 3. You can also do the same for objects. If that function returns an object in that shape, each of those fields you matched using ABC from that function return. Or you can do it as a shorthand. You don't have to go into the same named fields here. You can actually do it shorthand here. Or you can use it in function definitions as well. You can also specify default values for functions this way. It's a much more succinct way of getting data in and out of functions. ClojureScript also has this. It's the same as you'd find in Clojure. You can destructure anywhere a binding is expected. A binding is when you define something and give it a name. You can, so this here, M is defined to have a first, middle, and last fields, and then you can pull those keys out of the structure, and then after that line executes, inside those brackets, that scope, you'll have first, middle, and last defined, pulled automatically out of M for you. Or for numbers, and if you want to ignore a value, it's the underscore. They're function equivalent. Argument handling. Usually in JavaScript ES5, you have to mess around with the arguments value to argument to a function to try and get at extra arguments if more than one was passed and you didn't specify what they all were. ES6 formalizes that and gives you two operators called the rest operator and the spread operator. The rest operator means you gather everything that's passed into this function into this variable here. So you've got f, x, dot, 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 y. And if you pass in 3 values here, x will equal 3 and y will equal hello and through. And you can see what it's doing. That's kind of a funny function definition, but it works out of 6. The spread version here pulls apart a value you're passing into a function. So here, function f expects 3 values, and you're passing in an array 1, 2, 3 inside of it. You're given the 3 dot operator beforehand, so it explodes the array, and 1, 2, 3 then get passed in as x, y, z. ClojureScript has the rest matching A, B, and gather everything else into whatever you want to call that. The ampersand is a signal here, and you give it a name. It doesn't have the spread function, but it does have different functionalities built in by default. So it's actually, in some ways, nice. You can control more directly how you want to have responses to different arrays. Block scoping. JavaScript, if you declare a variable in JavaScript, but you don't use the var keyword to declare it, that variable goes all the way to the top of the global scope, and it's always visible for the rest of your program. So it's very, very hard to control the lifetime of that variable, how long it will live for. They've introduced a new keyword to try and handle that in the next version of JavaScript called let. Let tries to, or does, introduce a scope for a variable lifetime. So inside this block here, x is equal to sneaky, and you can't give it a different value there because you declared it const. And you've declared x up here. Once you've closed that scope, you can't redefine x again because it's always been declared in this block up here. It's kind of how you expect programming languages should behave if you ever use a different one. It's just escaping the weird JavaScript structure of vars and undeclared variables. And so I guess the only thing to say about ClojureScript there is that it works as you'd expect. For modules, for arranging your code, these are discussed earlier. You have some ad hoc tools at the moment in JavaScript, like AMD or CLJS. They're fine, they work, but they're competing ecosystems in some regard, and they do require some insight from the user into how to use those compilation functions, how to structure your modules in a certain way that the compiler picks up on them. ES6 codifies and improves it, so you now have keywords to export functions and to export variables, and then you have keywords to import these from locations. ClojureScript has all this, and through the namespace macro, which lets you pull in libraries, rename them, pull in certain fields from libraries, pull in certain functions in libraries, and export them as you see fit. It's richer. You can do a lot more. It won't let you create circular declarations, so you can't have a module A depending on a module B, which also depends on A. Sorry, that makes no sense. A depends on B, B depends on C, C depends on A. That's a circular definition. You can't. It stops you from making those kind of mistakes. So ClojureScript seems to anticipate and offer you things that ES6 is still working on at the moment. One of the best ones is Corda async against promises. Promises allow you to coordinate how network calls return values in your functions, how you structure those over time. Corda.async is essentially the Go language's Go routines. It automatically synchronizes transition points between functions, so you don't have to depend on arranging your code or having callbacks or structuring your code in a way that suits the network, the strange series of network calls you incidentally inherited from your code base. You can now just use a straight series of function calls in a line, and Corda async will take care of coordinating the network calls around those and having the code resume when that data comes in for you. It's actually incredible to see it just work for you, but you haven't to do anything about it. And all these strange things around promises, generators, and iterators, you just don't have to worry about in ClojureScript. ES6 is bringing in a lot more data structures, which are great to see. Weak maps are ways of augmenting an object that don't hit the garbage collector, so they won't stop your object being collected if you've got some extra information stashed in there. They're kind of obscure. ClojureScript ClojureScript really has a rich set of data structures already, but it doesn't need these kind of things around weak maps, weak sets, proxies, because its values over time, its values that don't change over time compared to JavaScript's values that do change over time, which is what demands these kind of strange proxies and symbols and weak maps. You just don't have to worry about it. There's a lot less to worry about. Macros are one of the best things ClojureScript has to offer. They're a way of transforming code to make it do more than you think a runtime can do for you. It's an obscure example, but Prolog is a logic programming language that lets you reason about data. You can ask it a query. It's like an advanced database. You can ask it to try and find a value that makes certain criteria for you. There's a version of it called core.logic inside Clojure that you can use in Clojure as well. You can use it in the browser. And it's basically a series of macros that take the function calls you put in to introduce that library and create this huge complex state machine behind the scenes that you can just ignore. It's a way of kind of abstracting complexity for you. You don't have to worry about how to specify these massive transformations in code yourself. That's not really an insightful example, but it's one of those things you have to actually try to see how it can change how you write code. You're getting the compiler to write code for you rather than writing code yourself. It can take the code you write from 1,000 lines down to 10 lines or less if you can do it properly. I'm still learning this myself, by the way. So, starting points for more. Why ClojureScript is a great review of what ClojureScript lets you do in the browser. The cheat sheet here as well lets you see at a glance the kind of the ways of translating between JavaScript to ClojureScript and vice versa. ClojureScript versus JavaScript is a detailed comparison with more code examples of what I showed you there before. And this is the Babel.io compiler that I spoke about for converting ES5 to ES6. It's really insightful as well. So if you had to decide between the two of them, you can't. The tooling around ClojureScript is painful still. It does liberate you from complexity, but you have to take a hit in terms of the day-to-day experience of compiling it. It's not as sweet as ES6 is at the moment. JavaScript, the next version of JavaScript is incrementally better. It'll run all your current JavaScript code and it won't take away anything bad that you've done to date. But it will give you some extra tools that will make things easier for you. ClojureScript, you can compile into JavaScript and interact with JavaScript code bases. You can use things like jQuery and everything else in there. But really, it wants you to step away from that whole mode of programming. It's a new way of thinking, a new way of interacting. It's painful to go through. Once you go through it, you do get a lot more done. And that's it. Thank you. Is there any questions? Nobody said I went too fast? That's strange.
Are there any large... Albert?
Oh, hello.
Are there any large kind of flagship apps which use ClojureScript in production?
There are some that use things like Facebook's React library covered with ClojureScript. I'm trying to think of a few. There are some in the States. Do a lot of things like data dashboards. You can't think of any, can you? Or is it Circle CI? Yeah, that's the one I'm trying to think of. Yeah, and they sponsor meetups here as well. Actually, I think so. Yeah. You guys to ask. They're not frameworks. There's code generators you can use that set up projects for you, like a web server or a website or blog site, whatever it might be. Clojure tends to give you libraries that you have to integrate yourself, which is very, very easy because Clojure gives you things like maps and arrays. It doesn't give you weird objects you have to try and dig into. It's very, very transparent in how it interacts. So the classic web library was something called Ring that lets you put together a web server in literally 3 or 4 lines of code. There's fantastic libraries for HTML generation that will work with anything. Fantastic libraries for parsing forms, validating forms, working with databases. They're all there, but they do let you pick and choose and almost generate your own framework from scratch in maybe half a day's work, or less.
You said that in terms of async code and stuff, you said that it takes care of a lot of that for you, but how does it do that? Like, how can you define whether or not you want it to do what it?
So it uses the concept of channels, which it takes them to go. If you ever,
Yeah, I've heard of it, but never.
So a channel is a channel is kind of an idea of things arriving down the channel for you, and if you try and take that value before it's there, your code pauses at that point, and then when a value comes down that channel, your code will automatically take it up again and keep going. So you just tell it that you want that value, and then your code will wait for it, and then it'll run some other part of your code for you. So there's no need to hide this stuff inside separate functions or use a certain kind of format to present your code into it. It'll just do it all for you inside the Go block. It sounds like too simple, but that's actually kind of...
It's the only thing to... Yeah, it's just to try it out, I guess.
Yeah, exactly, yeah. Good.
What kind of problems are there with the tooling? If I was going to come to this, what are the words of warning you'd give me?
Stick with it. Try not to quit too soon.
Other than compiling before you run it, like what
once you get the pipeline running in the background, it does it as you edit your code. So once it's up and running, it'll be fine. If you're on a laptop, your fan might spin up all the time, but that's kind of the only thing. But setting it up, you have to kind of dive into the ecosystem. You can't just kind of open up a text file. You have to pull down the Clojure build tool, install that, then pull down a sample project, get that running, and which, you know, it's a couple of steps, and if you're experiencing Clojure, it won't take much time. But if you're not, you have to. The initial hump is much higher, and a lot of your knowledge from JavaScript doesn't translate immediately. It does come back, but the initial steps are brave new world kind of stuff. So.
I'd imagine the JavaScript it produces is vastly different from the Clojure you're writing. So what's the debugging story like?
You can set the level of minification or optimization you want on the code that it spits out of the far side of the tool chain. So the initial, it has source maps for the JavaScript it spits out, and you can debug it that way. You can see exactly the line-for-line transformation between ClojureScript and JavaScript. And then you can compress that further or minimize it further once you go to production. So. Thank you.